Good morning, everybody. Today we are going to continue application of linear equations in one variable. We were working on example 3. Let's read example 3 here. Finding numbers of Olympic medals. In the 2016 Summer Olympics in Brazil, the US won 51 more medals than China. The two countries won a total of 191 medals. How many medals did each country win? So yesterday, we identified in this problem, we are looking for two unknowns, right? The number of medals for US, the number of medals for China. We brought in one variable X, and we agree we're gonna let X be the number of medals of the US. Since US has more medals, it's given in the problem, US won 51 more medals than China, right? So the number of medals of China would be X minus 51. So we were here yesterday. We use variable X represent both number of medals of China and number of medals of US. In order to know the value of X, we need to set up an equation, right? So let's see how do we create the equation. We need to read a problem to find the given information to set up the equation. Let's see. We have already used this information, right? US won 51 more medals than China. If we read on here, next sentence, the two countries won a total of 191 medals. Yeah, let's look at that information. I think, could we set up the equation by using the information here? Yeah, how do we understand 191 here? In total, together, they won 191 medals, right? Do we have an addition here? Addition, subtraction, multiplication, division? In total, does that mean a sum? Yeah, equal, yeah. Total of 191 medals equals 191. What equals 191? The sum of the two countries, right? Does that make sense? Yeah. So the medal from US, which is X, the medal from China, which is X minus 51, they add up to 191. Am I clear about that? Do you guys agree? Okay, so that's the equation. Now I'm going to give you 1 minute. Yeah, please help me to solve this equation for X. Let me know what do you have for X. You can use a calculator to assist you. The equation part actually is not difficult. The two countries won a total of 191 medals. So if we add up the number of medals from the two countries, we would have 191. That's the equation. Could we simplify the left-hand side a little bit? X plus X, what is it? X plus X, 2X, yeah, 2X. Simplify each side of the equation, right? 2X minus 51 equals 191. Do we want to get rid of negative 51 from the left-hand side? How do we do that? You can use my transposition of terms. Do you want to move it over? Could we move it over to the right-hand side? Yeah, we want to do that, right? Because we want to isolate the x on the left. Yeah, anyone has the result already? We need to isolate x on the left. Right now, on the left, we have 2x minus 51. How do we get rid of 51? We can add 51 from both sides, right? To both sides. Or we can move negative 51 to the right-hand side. We move it and then we change the sign. So we have 2x on the left, 191 on the right. The only term that has changed is negative 51. Now it's gonna be positive 51 on the right-hand side. Does that make sense, everyone? Okay, so tell me please, what is 191 plus 51? 242, awesome, thank you, very good. Almost there. Let me see if I can, yeah. Almost there. How do we isolate the x? Get rid of the coefficient 2. Divided by 2. Are you guys with me? Hello? Everybody's awake, right? Divide both sides by 2. So we have x isolated. On the right, what is 242 divided by 2? 121, correct? It's the same with your answer earlier. 121, yeah. So how do you answer this question? Let's look at the question. We are looking for how many medals did each country win? That's the question, right? Water problem, when you answer your water problem, you're gonna answer it in words as well. So you're gonna answer US won 121 medal. And then China, CN, how many medals China won? If America won 121 medals, how many medals did China win? Huh? You know that. More than 1-1 or less than 1-1? Less, how many less? The question tells us how many less? Yeah, 51 less. Do you see that? Everybody, do you see that? So the number of medals of China is 1-1 minus 51, right? It's right here. If x is 1-1, then x minus 51 is 1-1 minus 51. What is it? What is it? 70, 70, right? Yeah, so you can answer US won 1-1 medals, China won 70 medals, and that's the answer. Okay, in the last step, I recommend you always check your result. Let's see how do we bring the result to the original problem to see if they satisfy the original problem, okay? And in Brazil 2016, US won 1-1, China won 70 medals. And the number of medals won by US is 51 more than 70, right? Than China, right? So that is okay. And in total, they won 191 medals. Let's see, 1-1 plus 70. 1-1 plus 70 is 191, right? 121 plus 70 is 191. So the second condition is satisfied as well. Yeah. So means your answer is correct. Yeah, that's the process. Any question about this problem? We started this problem yesterday and we finished it today earlier. Any question? Okay, let's see example 4. Finding the number of orders for tea. Let's see what happened in this problem. The owner of Terry's coffee house found that on one day, the number of orders for tea was 1/3 the number of orders for coffee. Yeah, this is a very important condition, the number of orders for tea was 1/3 the number of orders for coffee. Yeah, let me highlight it. If the total number of orders for the 2 drinks was 76, yeah, that's another information, another piece of information that we can use later. We are looking for how many orders were placed for tea. So basically, the store offers 2 drinks, right? Tea and coffee. How's my drawing? Very simple, right? Tea and coffee. So what are we looking for? How many orders were placed for tea? We are looking for how many orders were placed for this, for tea, right? How about, let's say, very natural, because we are applying linear equation in one variable. Okay, let's bring one variable, which is x. Let's use x to be the number of orders for tea on that day. How about that? Yeah, so say I can write this way. Solution, let x be the number of orders for tea as I labeled here. Yeah, x is the label. X is the number of orders for tea on that day. We have another drink, right? Of course, this matters in this problem. How about let's figure out how do we use x to represent the number of orders for coffee? Let's look at the sentence in green. Let's look at the sentence in green. And tell me, on a day, more people ordered coffee or more people ordered tea? Read the sentence in green. The number of orders for tea was 1/3 the number of orders for coffee. Which one is more? It's a coffee shop. Coffee shop, if people order more tea than coffee, that might be weird, right? Of course, more people order coffee, right, than tea. Yeah. So if we have x orders for tea, how many orders for coffee? Yeah, think about that. Think about that. Read the sentence in green. Could I translate this sentence in green this way? May I have your attention? The number of tea is 1/3 of number of coffee. Does that mean the number of coffee is triple of number of tea? Yes or no? No? Okay, how about this? You have $1. I have $3. Is your money 1/3 of mine? Yeah. Does that mean my money is triple of yours? Triple, yeah, 3 times, right? Yeah, the same thing. Because tea is 1/3. That's given, right? Tea is 1/3 of coffee. That means coffee is triple, 3 times of tea. Does that make sense? Do you agree? Sunny, do you see that? Angela, do you see that? Okay. Yeah, so if we use x to represent the number of orders for tea, then the number of orders for coffee is triple it, 3 times x. And this is very important. How do you use the sentence in green to write the number of orders for coffee in terms of x as well, right? So they have x orders for tea, 3x orders for coffee. Okay, now we need to set up an equation, right? Let's see, how do we set up the equation? Another piece of information from the problem is the sentence in purple. Let's read the problem. Let's read the sentence in purple. The total number of orders for tea and coffee was 76. Was 76. Yeah, what do you think? Was 76. Yeah, we are creating an equation. Was 76. So we have equal 76, right? Yeah, let's see what is equal to 76. Total. When you see the keyword total means we have an addition here. Sum, right? It means the order of tea plus the order of coffee, 76. Does that make sense? Yes or no? 1 minute, please. Solve this equation and tell me what is x. Please solve the equation and tell me what is x. When we solve an equation, the first step in the guideline is to simplify both sides separately. The goal is always isolate x on the left eventually. On the left, we have x plus 3x, right? What is that? X plus 3x. Very good, perfect. Yeah, you can use calculator. This one is not too difficult, right? Yeah, that's correct. Okay, perfect. Yeah, do you have an answer? Simplify the left hand side. How to simplify the left hand side? No, you. Okay. How many terms in the equation? How many terms? 3 terms. 3 terms. Yeah. X, 3x, 2 terms on the left, right? Yeah. 76, 1 term on the right, right? On the left, are those 2 terms are like terms? X and 3x, they're like terms, right? Would you combine them? What do you have after you combine them? X, 3x. So let me show you what does that mean. X and 3x. This is 1x, right? 3x means 1, 2, 3. 3x. So you combine them together, what do you have? 4x. You know what I'm saying? So you have x here. You have x here, right? And you have another 3x. Yeah, 4x, exactly. You have a 1x here, right? And you have a 1, 2, 3, 3x there. So together you have a 1, 2, 3, 4, 4x. Do you see that? Yeah, combine like terms is to combine their coefficients. You can see this as an apple. X is apple, right? So you have 1 apple. I give you 3 more apples, then you have 4 apples. Does that make sense? Yeah, so after you simplify the left hand side, what do you have? Yeah, write it down. Write it down, please. You have a 4x on the left. 4x on the left. How do you continue from here? Isolate the x on the left. When you solve a linear equation in one variable, remember in the beginning I draw a bubble and write isolate the x on the left in the bubble, in the red bubble. So eventually you want to isolate the x on the left. You want to get rid of everything around the x. So here on the left we have 4 times x, right? How do we get rid of the 4 here? Divided by 4, right? Correct? Yeah, that's divided by 4. Divided by 4, divided by 4. And you tell me what is 76 divided by 4 in? Yeah, you tell me. You have a calculator? If you don't have one yourself, you can always borrow a scientific calculator from a Student Success Center. Use your student ID for the test. What is it? 19? Perfect. Very good. Exactly, 19. So you can answer the question. Yeah. So on that day, they sold 19 waters for tea. Okay. Yeah, you answer what they asked. You answer the number of waters for tea, which is 19. Okay, it doesn't hurt always check your result, right? So let's bring the answer back into the original problem to see if the result satisfy all the conditions in the problem. Yeah, if we have 19 orders for T, triple of 19. Anyone can tell me what is triple of 19? 3 times 19, what is 3 times 19? 57, right? Yeah. So if they have 19 orders for tea, then they have 57 orders for coffee on a day. Add them up, 57 and 19, we have 76. So it satisfies the original problem. Means our answer is correct. Does that make sense? Everybody, does that make sense? Angela? Very good, perfect. Let's move to the next example. Finding consecutive integers. So this is a number problem. Pretty much a number problem. Okay, 2 pages that face each other in the print edition of this book has 277 as the sum of their page numbers. What are the page numbers? Yeah, a book. Yeah, let me see. Do I have a book? Do I have a book? Anyone has a book? Okay, so if you have a book, right? Let's say this is a book. If this is page 1, what's this page? Page 2. Does that make sense? Because they are consecutive, right? Consecutive. Okay. So let's say you have a book. So this page and this page, they are 2 consecutive pages, right? Yeah. So if this page is X, then the other page would be X plus 1. Do you agree? Yeah, if the page on the left is X, number X, then the one which next to it would be X plus 1, right? Do you agree? Yeah, 2 pages that face each other, then their page numbers must be consecutive, yeah, consecutive integers. If the page on the left has page number X, then the one next to it would be X plus 1, right? Does that make sense? Yeah, so that's what we are looking for. We are looking for the page numbers. What are the page numbers? Yeah, we are looking for X and X plus 1. In order to find a value for X and X plus 1, we need an equation. Yeah, please read the problem and you guys tell me, how do we set up the equation here? You guys tell me, how do we set up the equation here? 2 pages that face each other in the print edition of the book have 277 as the sum of their page numbers. Yeah. How do you take advantage of that information? I'll give you a couple of minutes. Let's see if you can get an equation done. Yeah, the sum of them is 277, right? Is it together equals 277, right? You have it. Yeah, you have a book. You have a book. Well, that's weird in the class. Yeah, good, good. See this book. Any page, right? If this is 102, then these 2 pages face each other, right? If this is 102, this must be 102 plus 1. 103. Anything like that. Yeah, these 2 pages face each other, right? This is 36, and that is 36 plus 1. 37. So if this is X, if this page is X, then this page is X plus 1. That makes sense? Yeah. Yeah. So and the page numbers of the two page numbers add up to 277. Does that mean x and x plus 1, if you add it together, you should have equal to 277, right? Yeah, that's how you read it. All right, guys, do you have the equation? Please let me know. What is your equation? The two pages, the sum of their page numbers is 277, right? Look at the sentence in purple. Yeah, equals 277 is sum, right? Yeah, sum of what and what? Sum of the two page numbers, x and x plus 1, they add up to 277, right? Okay, you guys solve the equation and tell me what is x. 276, 1, 3, 8, right? 138, yeah. So if we simplify the left-hand side, Ian, can you help me to simplify the left-hand side? So far, you have 3 terms on the left. 1, 2, 3. Can you simplify them? Yeah, combine x and x, right? So what do you have? 2x plus 1. Very good. 2x plus 1 equals 277, right? Very good. Do you want to get rid of the 1 from the left-hand side? How do you do that? Let me color it orange. So what do we want? Remember, I told you this is the anchor, right? Yeah. 2x stay. Doesn't change nothing. 277 stay on the right. Doesn't change anything. The orange term, you moved over. So are you going to have a positive 1 on the right or a negative 1 on the right? Huh? Remember, you move a term from one side to the other side, you have to change the sign to the opposite. So negative 1, do you see that? Yeah, very good. So what is 277 minus 1? 276 obviously, right? And how do you continue from here? Divide both sides by 2 because we need to isolate the x. And after we isolate the x, let's see what do we have for x. You can use your calculator. 138? Does that make sense? Yeah, you can always use your calculator. Divide 276 by 2, you have 138, right? So you can answer the question. And the book, the 2 pages we are looking for, they are page 138 and 139, right? Yeah, you can look at your book, find 138 and 139. They are facing each other. They face each other, right? They face to each other. And the 2 page numbers add up to 277. You can check your answer by bringing the result into the original problem. Does that make sense? Yeah, practice. As I said, all those examples in the class, they are good examples. Repeat them like 5 times. Any question about this problem? Okay, next one. Finding consecutive odd integers. Let's see. If the lesser of 2 consecutive, yeah, this is a number problem. The lesser of 2 consecutive odd integers. Yeah, we need to take time to understand what does that mean. Consecutive odd integers. Okay, let me write some odd integers. Okay, of course we have infinitely many odd integers. Let me write some of them. 1 is an odd number, right? 3, 5, 7, 9, 11, and so on. Of course, we have more. Or we have -1, -3, -5, and so on, right? Yeah, those are all the odd integers, correct? Correct? Yeah. Let's see consecutive odd integers. Yeah, consecutive odd integers. Do we have a pattern for that? consecutive odd integers. For example, those two. What's the difference between the two consecutive odd integers? Difference. Any two consecutive integer, odd integers. Odd, ODD, odd integers. Yeah. So we have those integers are odd integers, right? Let's take any two consecutive odd integers and let's see the pattern. Is the bigger one two more than the smaller one? Smaller one is two less than the bigger one. Okay, let's try. Let's see the pattern. You will see they are always like that. See these two? Same thing, right? The bigger one is two more than the smaller one. Yeah, those two. Yeah, those two. Always like that. Do you see that? Any two consecutive odd integers, the smaller one is two less than the bigger one. In other words, the big one is two more than the smaller one. Does that make sense? Okay, let's read on. If the lesser of the two consecutive odd integers is doubled, the result is 7 more than the greater of the two integers. Okay, so you can see you have a equal sign here, right? IS, that means equal sign, right? Yeah, okay, so let's see, what are we looking for? We are looking for the two integers. We need to find our target. We are looking for the two consecutive odd integers. We have one variable only. We have one variable only. Okay, here. The two other consecutive integers must one is smaller, the other is bigger, right? Yeah, okay. Which one do you want X to represent for? Which one do you want to assign to X? Do you want X be the smaller number or do you want X be the bigger number in the two consecutive odd integers? Ian, you tell me, do you want X be the smaller one or bigger one? Okay, so let's say X, let X be the bigger number among the two consecutive odd integers. Then the smaller number would be what? If X is the bigger number, then the smaller number should be what in terms of X? Because I just show you the pattern. Any two consecutive integers, the bigger one always is two more than the smaller one, right? Well, the smaller one is always two less than the bigger one, right? So if the bigger one is X, what's the smaller one? You guys tell me. Huh? Yeah, I hated to answer my own question. So if X is the bigger number, what's the smaller number? X plus 2, X minus 2. Perfect. X minus 2. Does that make sense? For example, if X is 9, X minus 2 is 7, right? 9 and 7 are the two consecutive odd integers. Bigger one, smaller one, right? If X is 11, X minus 2 is 9. So always satisfy the pattern. So those two numbers are the two consecutive odd integers. So once again, you need to remember, you use X to represent the bigger number among the two consecutive odd integers. Okay, now let's set up the equation. Remember earlier I mentioned equals, right? Is 7. 7 what? 7 more than. How about deal with the right-hand side of the equation? What is 7 more than the bigger? What is 7 more than the greater of the two integers? Which number is the greater of the two integers? Which number is the greater one? X minus 2 is the bigger one? X is the bigger one. You see that? X is the bigger one, right? 7 more than X. Do you see that? Yes or no? Okay. On the left, what is 7 more than X? If the lesser of the two numbers is doubled, double means what? What does that mean? Double. If you have $10, I double it, you have $20, right? Do you multiply by 2? Double. Double what? Double the smaller number. Okay, let's see. This is the smaller number of the two consecutive odd integers. This is the bigger number of the two consecutive odd integers, right? If the lesser, which is x minus 2, right, is doubled, means multiplied by 2, right? Equals is 7 more than the bigger number. Then that's the equation. Do you see that? Do you see that, Sammy? Ian, do you see that? Angela? Okay, you solve this equation. I'll give you a couple minutes. Please solve this equation. Well, you might have to distribute in this case. And tell me what is x. What is x? Yeah, let me walk around and let's see how you guys solving the equation. Let's see how you, oh, great. So x minus 4 to the x equals 11. Perfect. So you're gonna know the two integers are 11 and what? Two integers, right? 11 is the big one versus the smaller one. You found that the value of x is 11, right? Means 11 is bigger than versus smaller. That is true. Right, right? And then minus 2. Distribute. When you need distribute. Yeah. Distribute. So after you distribute, you have two terms on the left, two terms on the right, right? Remember the method we learned, terms without terms. Do you want to move this x over? Do you want to move this -4 over? So you will have a negative x on the left, a positive on the right, right? Like that. Okay, 2 times x is 12, that's great. 2 times -2. 2 times -2. What is 2 times -2? 24. Yeah. Yeah, let me write a distributive property for you. We learned distributive property, chapter 1, right? Yeah. Distributive property. A times parentheses B plus C equals A times B plus A times C, right? So the coefficient of the parentheses is 2. When you distribute, you're gonna use 2 to multiply each single term in the parentheses. So you have 2 times x, 2x. 2 times -2, -4, right? Yeah, every single number in the parentheses is gonna be doubled. Yeah, equals on the right-hand side, we have 7 plus x. I'm going to apply my method, transposition of terms here, okay? Yeah, before that, maybe I'm going to color them and you can see better. Those are 4 terms. I want those 4 terms. I want the green, blue and purple together. Again, you see this equal sign is the anchor, right? Yeah, I want a blue and a purple on the left. Okay, I bring down blue. Nothing have changed. I'm going to move the purple over. Positive becomes negative, right? Yeah, whenever you move a term from one side to the other side, you have to remember to change the sign to the opposite. Super, super, super important. Do you see that here? Okay, on the right, I'm going to keep the 7, the orange, I don't change nothing. I'm going to move the green over, move the green over. Negative becomes positive, right? Positive 4. Negative becomes positive. Do you agree what I did? Okay, you need to practice, you need to repeat. Then you can do it later yourself. Okay, so why did we do that? Because we have to collect like terms in order to combine them, right? We cannot combine like terms when they are on different sides of the equation. Now the like terms are on the same side. On the left, we have 2x minus x. What is 2x minus x? 2x minus x, you have 2, okay, you have 2x. I take away 1. 1x. Does that make a perfect sense? Yeah. 2x minus 1x. You have 1x. What is 7 plus 4? 11. Right? Yeah. So 11 is the bigger number. Then 9 would be the smaller number, right? So the two consecutive odd integers are 11 and 9. Yeah, they are consecutive. Yeah, they are consecutive. And the lesser one, which is 9, if it's doubled, then we have 18. 18 is 7 more than the bigger. 7 plus 11, 18, right? Yeah, so it satisfies the original problem. Super again. Okay, we have 12 minutes. We are going to cover this problem. Super important. The reason is super important because test 1, we are going to have a problem very similar with this problem. Yeah. What kind of problem this is? This is a mixture problem. Yeah, mixture means for example, if you put water and you put salt, you would have a mixture of water and salt, right? If you put water and sugar, you would have a mixture of water and sugar. So that's kind of the thing like that. Let's read the problem. Yeah, we need to finish this in 12 minutes. A chemist mixes 20 liters of a 40% acid solution. Let me explain what is an acid solution. A solution means water with something. So salt solution is water with salt, sugar solution is water with sugar. Acid solution is water with acid. You pour more water, then the acid would become like more, density is lower, right? If you put a little water, then the density would be higher. Yeah. So this chemist mixes 20 liters. Yeah, the mixed number means they pour different density stuff in the same jar to make make a new type of solution. So 40% acid solution with some 70% acid solution to obtain a mixture that is 50% acid solution. How many liters of the 70% acid solution should she use? Okay, mixture number. Let me explain. Let me say the better this time. Mixture problem means this person has 2 containers, right? Yeah. In this container, she has like a 40% acid solution. In this jar, she has 70% acid solution. And she poured the content in the 2 jars in a bigger jar. She wants to make the big jar has 50% acid solution. And look at this, 20% is lower density, right? 70% is very strong, right? So kind of like neutralize them. She wants 40%, she wants 50% acid solution. So that is a mixture number, mixture problem. Am I clear what's going on in this problem? Am I clear about that? Yeah, yeah. She pours stuff here and stuff here into here. She wants in this jar, the acid solution is 50% density, means half acid, half water. Here, 70% acid, 30% water. So this is very strong. This is a 40% acid, 60% water. So this is not very strong. So she mixed them together. She wants like a half acid, half water. Am I clear about what's going on here? Okay. What are we looking for? We are looking for how many liters of 70% acid solution should she use? How about let's say X liters? How about let's say X liters? That's what we want to look for, right? Yeah. Then we use X to represent the number, the quantity we are going to look for. We are going to find. Let's say X is the number of liters of 70% acid solution here. Okay? Yeah. Yeah. How many 40% solution she used? That is given. How many liters? How many liters? 20 liters? Yeah, it's given, right? So she used 20 liters here. She used X liters here. Yeah, what she did is she poured 20 liters here, X liters here. So how many liters in this big jar? Everybody, she put 20 liters here and another X liters here. How many liters in the big jar? Huh? This is X. You have 20 liters, you put it here. You have X liters, you put here. So how many liters right now here? It was empty here. It was empty, the big jar, the beginning. The chemist put 20 liters, 40% acid solution here, and then put X liters, 70% acid solution here. Then how many liters solution right now here? 20 plus X. Yes? Do you see that? 20 plus X liters. Do you agree? Do you see that? 20 plus X, of course. Yeah? Okay, you put 20 liters here. I put X liters here. So now it has 20 plus X liters, right? Okay. How do we set up the equation? Yeah, that's the harder part. How do we set up the equation here? I want to ask you how many liters acid in this container? In the blue. In the blue, yeah. How many liters acid in the blue container? Huh? How many liters acid in the blue container? Acid in the blue. Acid in the blue container is 40% times 20. Why is it like that? 40% off. Off means multiply, okay? For example, you have 10 apples. I take a half of 10 apples. That is 5 apples, right? So in algebra, OF, you translate the OF as a multiply. 40% off 20 liters. So that is 40% times 20. That is how many liters of acid in the blue container. Do you guys agree? Okay, so I see you nod. How about Ian? Okay, so how many acid in the black container? Acid in the black container is how many liters? 70% of X. It has X solution, right? X liter solution. 70% of 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 them are acid. So 70% times X. Does that make sense? Okay, very good. Now, how many liters acid in the red jar, in the red container? Yeah, how many liters acid in the red container? That is 50% of OF means multiply, right? Multiply 20 plus X means half of 20 plus X is acid. Does that make sense? Ian, do you see that? Okay, you guys tell me what's the relationship or connection between this, and this, and that. This means how many liters of acid in this red jar, right? Where the acid in the red jar come from? Is the acid in the red jar come from acid in the blue and acid in the black? Yes or no? Huh? Yes or no? Okay, the relationship is this. So do you agree? This guy plus this guy equals this guy. Do you agree? The acid in the blue plus the acid in the black gives you the acid in the red. Right? Okay, let's write it down. That's the equation. That's the equation in order to solve for X. So we have 40% times 20 plus 70% times X equals 50% times parentheses 20 plus X. That's the equation. Well, we have 2 minutes to solve the equation. Might be challenging. Let's see how do we do that. How many terms in the equation, by the way? How many terms in the equation? For this guy with parentheses, we can temporarily see that as one part. Of course, if you distribute, you will have 2 terms, right? Yeah, but let's pretend that is one part. Yeah, so 1, 2, 3. Do we have 3 parts in the equation? Do all the 3 parts have a percentage symbol here? Percentage symbol. Yes or no? If all the 3 parts have the percentage symbol, we can remove them all. Remember, for the equation, all it matters is the balance, right? If we treat the left-hand side and right-hand side the same way, then the scale will always keep the balance. That will be enough, right? So as long as we apply the same treatment to the left and the right, we'll be okay. So what treatment? I'm going to remove the percentage symbol, remove them all. Remove them all. Yeah, that's the easy way. Okay, so we have 40 times 20 here, plus 70 times X. On the right, we have 50 times parentheses 20 plus X. All right? And I think I want you to write that on your note and you work on your own. And maybe we continue here on Monday because we run out of time now. Okay? Thank you guys for coming. Have a good week. I'll see you on Monday.